Now come to the question number 4. Using the properties of determinants and without expanding, prove that det 1 BC A into B plus C, 1 CA B into C plus A, 1 AB C into A plus B is equal to 0. Now we have to prove that the determinant of this matrix is equal to 0 by using the properties of determinants, not by expanding. Understood the question, my dear children? We should not use the expanding technique here. We should use only the properties of determinants. Now let us consider the given determinant is delta. So delta is equal to det 1 BC A into B plus C, 1 CA B into C plus A, 1 AB C into A plus B. Just we assumed, we considered the given determinant is delta. Okay, my dear children, understood this question? Understood this step, my dear children? Right. That is equal to 1, 1, 1. First column we wrote as it is. Second column elements also I wrote as it is, BC, CA, AB. In the third column we multiply, two expressions are there, so we multiply A into B, AB, plus A into C, AC. Understood this term, my dear children? Next, B into C plus A, B into C, BC, plus B into A, AB. Understood this third term in the second row? Understood, my dear children? Right. Now C into A, CA, plus C into B, BC. Understood the third term in the third row, my dear children? Right. Now we apply this operation on C3. C3 implies C3 plus C2. We are adding these two columns, but we should all add all these elements to the C3 only. Okay, my dear children? Then we get det first column as it is 1, 1, 1. Second column also as it is BC, CA, AB. Here only third column is changing. How it is changing? C3 plus C2. So AB plus AC plus BC. If you are adding these three terms, what you get? AB plus BC plus CA. Again we are adding, if you are adding these three terms, what will you get? AB plus BC plus CA. Understood this step, my dear children? Right. Now, if you observe all the elements in the C3, all the elements are same. So, we take it this common factor in the C3. We can take it out the common factor AB plus BC plus CA from C3. Then we get, see here, taking out the common factor from C3, we get AB plus BC plus CA det first column as it is 1, 1, 1, second column also as it is BC, CA, AB. By taking this factor out, we get the third column elements 1, 1, 1. Understood this step, my dear children? Right. That is equal to AB plus BC plus CA, we wrote this as it is, into determinant of this matrix is 0 because C1 and C3 are identical, because here 1, 1, 1, 1, 1, 1. Understood, my dear children? Right. Therefore, delta is equal to 0. Hence, proved. Understood, my dear children? Right. Now come to the question number 5. Using the properties of determinants and without expanding, prove that B plus C, Q plus R, Y plus Z, C plus A, R plus B, Z plus X, A plus B, P plus Q, X plus Y is equal to 2 determinant A, P, X, B, Q, Y, C or Z. We have to prove this statement by using the properties of determinants, not by expanding the determinant. Understood the question, my dear children? Right. First of all, let us assume that delta is equal to det B plus C, Q plus R, Y plus Z, C plus A, R plus B, Z plus X, A plus B, P plus Q, X plus Y. We are assuming this given determinant as delta. Now we apply this operation on R1. How it is taken R1? R1 plus R2 plus R3. Here R1 is changing, not R2 and R3. Remember this point. Before arrow symbol, whatever the letter is there, that row or that column only changes. Okay, my dear children, remember that point. Then we get, by adding the R2 and R3, for R1 we get B plus C plus C plus A plus B, Q plus R plus P plus Q, Y plus Z plus X plus Y in the first row. We write second row elements as it is and third row elements also as it is, because only R1 is changing. Understood this step, my dear children? Right. Now by simplifying these terms, we get 2 of A plus B plus C. Here also by simplifying, after simplification we get 2 of P plus Q plus R. Here also by simplifying these three terms, we get 2 of X plus Y plus Z. Just we simplified the elements in the R1. Understood, my children? In this step, just we simplified the elements in the R1. We are writing the elements in R2 and R3 as it is. Understood this step, my children? Right. Now, if you observe the elements in the first row, you can find that 2 is a common factor, isn't it or not? So, we can take it out from R1, 2 is a common factor. Then, we get here the next step, 2 of, okay, my dear children, 2 of det. We write all the elements as it is, A plus B plus C, P plus Q plus R, X plus Y plus Z. Second row elements we write as it is, and third row elements also we write as it is. Understood this step, my dear children? Right. Now applying R2 gives R2 minus R1 and R3 gives R3 minus R1. Here we are changing the row to second row and third row with the help of R1. Okay, my dear children. Then we get here R1 as it is. We write R1 as it is, A plus B plus C, P plus Q plus R, X plus Y plus Z. Then by applying this operation, we get these elements in the second row, minus B, minus Q, minus Y. And by applying this operation, we get these elements in the third row, minus C, minus R, minus Z. Understood these two rows, second row and third row elements, my dear children? Right. Now if we observe here, minus is common from R1 and minus here also in R2. So taking out common factors minus 1 and minus 1 from R2 and R3 respectively, we get that is equal to 2 of minus 1 into minus 1 that we have taken out these two factors out. Understood, my children? That A plus B plus C, P plus Q plus R, X plus Y plus Z. We wrote first row elements as it is. From the second row, we have taken out minus common. So the elements becomes like this, B, Q, Y. Similarly, in the third row also, we have taken out minus. So here we get C or Z in the third row. Understood this step, my dear children? Right. Now applying R1 gives R1 minus of R2 plus R3. Here we are changing the R1 by using this operation. We get that is equal to 2 of det. By using operation, by applying this operation, in the first row we get A, P, X. Second row elements we write as it is, and we write third row elements as it is, P, Q, Y, C or Z. That is nothing but RHS. Therefore LHS is equal to RHS. Hence the given statement is proved. Understood, my dear children? Right. Now come to the question number 6. Using the properties of determinants and without expanding, prove that 0 A minus B minus A 0 minus C B C 0 is equal to 0. Here also we have to use the properties of determinants, not expanding the determinant. We have to show that the determinant value of this matrix equal to 0. Understood the question, my dear children? Right. Now come to the solution part. Let delta is equal to det 0 a minus b minus a 0 minus c b c 0. Understood this step, my children? We assumed that like that. Now by interchanging the rows and columns, that means we are taking the transpose of this matrix, then we get delta is equal to det. We are writing this first row as first column, means 0 a minus b, 0 a minus b. We write second row as a second column, minus a 0 minus c. We write third row as third column here, bc0. We write this third row as third column, bc0. Understood, my dear children? Because det A is equal to det A transpose. This is also properties of determinants. That is why we wrote this step. Understood this step, my dear children? Now taking out common factors minus 1 comma minus 1 and minus 1 from r1 r2 and r3 respectively, from r1 as well as from r2 and from r3 we are taking out minus. Okay, my dear children? Right. That is equal to delta is equal to minus 1 into minus 1 into minus 1 into the first row elements changes like this, 0 a minus b, after taking out minus common factor out. Similarly, in the second row the elements will change like this by taking out minus 1 out common factor. Similarly, the third row elements becomes like that because we have taken out minus 1 common factor. Understood this step, my dear children? Right. This implies delta is equal to, here minus 1 into minus 1 into minus 1. What will you get? Minus 1 into, we write this determinant as it is 0 a minus b minus a 0 minus c b c 0. If you observe this determinant, it is nothing but delta. Therefore, delta is equal to minus of this one delta, because delta is equal to the given determinant only. Now we bring the minus delta to LHS. This implies delta plus delta is equal to 0. This implies 2 delta. What will you get? X plus x, 2x. Similarly, delta plus delta, we get 2 delta is equal to 0. This implies delta is equal to 0. Hence, the given statement is proved. Understood this step, my dear children? Right. Now come to the question number 7. Using properties of determinants and without expanding, prove that det minus a square ab ac ba minus b square bc ca cb minus c square is equal to 4a square b square c square. We have to prove that the determinant of this matrix is equal to 4a square b square c square. Understood this step, my dear children? Now here we have to use only properties of determinants to show this statement, not using the expansion technique. Okay, my dear children? Now if you observe here, in RHS 4a square b square, 4 is one factor, a square is another factor, b square is another factor, c square is also another factor, and moreover a into a, b into b, c into c also factors. So totally there are 7 factors. What are that? First factor is 4, second factor is a, third factor is also a, fourth factor is b, fifth factor is b, sixth factor is c, and seventh factor is also c. Understood these factors? Now to show this statement, we try to get common factors. These are 7 common factors one by one out. Okay, my dear children? We concentrate, we focus on taking out these one of these common factors one by one, step by step we get these common factors out. Okay, my dear children? Now let us consider the given determinant is delta. Delta is equal to det minus a square ab ac ab minus b square bc ca bc minus c square. Now taking out the common factors a b and c from r1 and r2 and r3 respectively, we get, okay, my dear children, what I said, we have to take out common factors as far as possible, as many as possible we take out the common factors out. Then delta is equal to A into B into C, that if you take the common factor A from this R1, what will you get here? Minus A. Here B only, here C only. From this second row, if we are taking out B common factor, here B will be, A will be left, here minus B will be left, here C will be left. Understood the elements in the second row, my dear children? Similarly, in the third row, we are taking out C common factor out. Then what will you get? Here A, here B, here minus C. Understood this step, my dear children? Right. Now, again, if you observe, first row A is common factor, B is a common factor in second column. Okay, my dear children. In the third column, C is common factor. So, taking out the common factors A, B, and C from C1, C2, and C3 respectively, we get, this implies delta is equal to ABC into ABC. We have taken out these three common factors from C1 and C2 and C3 respectively. Understood, my dear children? Right. Into that minus 1, 1, 1. From the first column we have taken out A, so we get minus 1, 1, 1. From second column we take it out B, so we get these elements. So in the second column 1 minus 1 B. From the third column we have taken out C, so in the third column we get 1, 1 minus 1. Understood, my dear children? Right. This is equal to, what will you get here by multiplying these factors? A, B, C whole square. That we are writing this determinant as it is. Again, we are using the properties. By applying R2 implies R2 plus R1 and R3 implies R3 plus R1, we get. Here we are using these two operations. Okay, my children. To find the determinant of a matrix, we focus on making any two elements in any row or any column. To make any two elements in any row or any column, we focus on it. Okay, so that is why we are using these operations. Understood, my children? This implies delta is equal to ABC whole square into, we write first row as it is. Here only second row and third row are changing. By applying this operation on R2, we get 0, 0, 2. By applying this operation on R3, we get here 0, 2, 0. Understood the elements in R2 and R3, my dear children? We have wrote R1 as it is. Okay, my dear children? Right. Here we got more number of zeros in C1. If you observe here, the elements in the C1, two zeros are there. So, by expanding the determinant along C1, we get, this implies delta is equal to ABC whole square into, we are expanding the determinant along C1, then we get minus 1. You should remember my sign matrix, plus minus plus minus plus minus. Okay, my children, you have to remember that sign matrix. Okay, so by expanding the determinant along C1 we get minus 1 into that 0, 2, 2, 0, minus 0 into 1, 1, 2, 0, plus 0 into 1, 1, 0, 2. Understood, my children? This was right. That is called ABC whole square into, here this term is 0, this term also becomes 0. So we get this only, minus 1 into 0 cross multiplication, minus 2 into 2. Understood this step, my dear children? Right. This implies delta is equal to ABC whole square into minus 1 into, what will you get in this brackets? Minus 4. Understood this step, my dear children? Right. This implies delta is equal to ABC whole square into, here by simplifying these two numbers we get 4. Okay, my dear children? This implies delta is equal to 4A square B square. Okay, my children. Hence, the given statement was proved. Understood, my dear children? Right.